Alright guys, so in this case for number 4, we have circle C. They're asking us to find AD, CD, and measurement of arc AB. So here I'm looking at this triangle here, and right off the bat I'm noticing that it's a 30, 60, 90 degree triangle. So I have it drawn over on this side, and from last chapter you remember that, so right across from my 60 degree, this is 60 degrees, so that means this is going to be my long side. So I'm going to just go ahead and write L, and then this is 30 degrees, so across from it will be my short side. So if you remember, to go from my hypotenuse to my short, I'm going to go ahead and divide by 2. Therefore, 6 divided by 2 is 3, so this side is 3. And then to go from my short to my long, I'm going to go ahead and multiply it by the square root of 3. So that means this is going to be 3 square root of 3. So looking here, I know that AD is going to be square root of 3. CD is 3. Now they're asking me to find measurement of arc AB. Well, if you notice, this is a central angle right here, right? So if this is 60 degrees, that means this arc AE is 60 degrees. So I'm going to go ahead and write that down. So I have measurement of arc AE. Actually, if you notice, AE plus EB is going to be measurement of arc AB. So let's go ahead and just write that equation down so we can see what we're going to do next. So measurement of arc AE, well, if this is 60, that means this arc is going to be 60. And then if you remember that from this theorem, it tells us that if a diameter or a radius is perpendicular to its chord, then it bisects the chord and it is in its arc. So because it is perpendicular to this chord, then it's going to bisect this and this, right? It's bisecting this whole thing, and that means this arc is going to be congruent to this arc. So if this is 60, then EB also has to be 60. And that's equal to the measurement of AB. And then 60 plus 60 is 120. Okay. And there you go. We have this one, and this one. Alright guys, so now that we answered all 3 parts, we're done with number 4. So let's go ahead and start with number 6. So in circle A, we have FG equals 3x minus 4, and HJ equals 14. Find the value of x. So for this one, we're using theorem 10.9. So again, 2 chords are congruent if and only if they are equidistant from the center. So if you notice right off the bat, these are equidistant from the center, therefore we can assume that FG and HJ are congruent. So I'm going to go ahead and set these two equal to each other on this side. So I have 3x, so this is right here is, let me just go ahead and label what I have. FG is equal to 3x minus 4, and then HJ equals 14. So I'm going to go ahead and set them equal to each other. So 3x minus 4 equals 14. I'm going to go ahead and add 4 to both sides, and then I get 3x equals 18. When I divide both sides by 3, I get x equals 6. And that is my answer, right? They asked to solve for just the value of x. They didn't tell us to go ahead and find FG, otherwise I would have had to go ahead and plug this into there. But it seems like we are all good. And this is my answer. Yay! Alright, so hopefully this is it for the problems for this lesson. Hopefully they all made sense, and if not, go ahead and rewatch those videos. And I think they should make sense. Okay? Alright guys, see you next time. Bye!